Oh, hey guys. Today I'm going to be talking about a program I wrote for Intro to Feminist Theories as a final project. My project's called the Passerby Simulator, and I wrote it in Python. And the gist of what it does is it takes US Census data and Gallup poll data and then recreates a random encounter of a person you may encounter throughout the United States. Or it also gives you the opportunity to simulate different scenarios with different sizes of groups of people that you may run into across the US. And I did this out of curiosity of how many LGBTQ people are there out there in the United States, which is actually a very difficult question to answer, partly due to maybe response bias or non-response bias when there are polls from the US Census or from the Gallup poll of people maybe not wanting to identify as LGBTQ for whatever reason and that there may be. So the Gallup poll actually has had increasing numbers of a percentage of people who identify as LGBT. From the past few years, it goes up about 0.4%, I think, every year. Now to the point where it's 4.5% of people that they polled identified as LGBT. So I will pull up the code, and I wrote this in Python, the language Python. And in order to run this code, you'll need Python 3.7.1, and I've included a video link, not a video link, a download link in the description below of where to download that. And then you'll also need to set up your environment variable to run Python in case the Python installer doesn't do that, which I've also included a link down below. So I will start running through the code now. So simulation.py is the class that starts the simulation. It starts to print out of the options, also with other data. And from the console, you'll be able to input a number and select one of these scenarios where it'll generate a certain number of persons. And that will skip over to the scenario class. And scenario houses those different scenarios from encountering one person all the way up to 50,000 people. This is the class that will handle that and generate the persons. It also stores the persons and various statistics about the group of people. So this class will then call person, and person is a class that is generated for each person of the simulation. So if you generate one person, you'll have one person class. 50 persons will have 50 instances of a person class. And the cool thing about the person class is that this class will call statistics, which houses the statistics from the US Census and the Gallup poll, along with some stats about the percentage of people who are intersex. So a person will initialize and start beginning by calling different methods that will initialize things such as their age, their sex, if they identify as LGBT or not, if they're Hispanic, and their race. And an interesting thing about the US Census is that the US Census classifies people who are Hispanic as an ethnicity and not a race. So any of the races that the US Census collects in its categories can or cannot be Hispanic, if that makes sense. So after calling these methods to initialize variables about the person, it'll call statistics, which reads in CSV files that I've formulated with US Census data. And I'll pull up one of these just for an example, maybe age. And the CSV file for age has integers from 0 all the way down to 100. And each of these float numbers is the proportion of people from the US Census that were that age, plus the last number. So for 1.01197 of people from the U.S. Census were age 0, in between 0 and 1. And then from the age 1, 0.024 minus this was the proportion of people that were aged 1. And I did this specifically, you'll see why, over in the statistics class. And there's also additional CSV files for Hispanic and female race by age, Hispanic and male race by age. I had to break down the U.S. Census data into specific categories of CSV files with float number proportions in order to simulate the data. So I guess we'll start with age. Age is the first functional dependency that all the other variables are based off of, except LGBT and intersex, because there are a certain number of proportions of people per age that the U.S. Census has recorded, and from there there's a certain proportion of sexes per age proportion, and then from there the proportion of people who are Hispanic that are a certain sex and a certain age, and then again a certain proportion of people who are a race that are Hispanic and or not Hispanic and a certain sex and the age. So person will start by calling age, which it determines via a random, down in this is the method, it'll determine a random float number, it'll pull one out, and then if this float number is less than or equal to that first proportion from the CSV file, then it will return 0 as the age. But if that random float number is greater than that first number, then it'll hop to the next one, and it'll keep comparing to see if that random number is less than or equal to the float number by the age, all the way down to 100 years old. So after this age is determined by person, all the other variables can be determined except LGBT and intersex. Those ones are just called with a default variable that was determined by the Intersex Society of North America. Did studies, and I included the links to all of the places where I got my data. Did a study, and 0.0006, so about 1 out of every 1,500 people are born with intersex traits. And then the same with the Gallup poll. They did a random nationwide survey where they determined that 0.045% of people identified, not percent, proportion, sorry, identified as LGBT. So 4.5% of people from the study identified as LGBT. And those will just be determined with another random number. And if that number is less than or equal to that proportion of LGBT or intersex, then it'll return a true variable to that specific person's data. And then I guess I'll run through sex. So after age is determined, there's a certain proportion of people who are male or female for that age bracket. So then sex is determined. And then the same with people of Hispanic or not Hispanic descent. There's a certain proportion who are a certain sex and a certain age. So then that is determined. And then race is finally determined. And race is actually broken up into these categories by the U.S. Census. So the U.S. Census groups people by white, black, Native American or Alaskan, Asian, Native Hawaiian or other Pacific Islander, and then 2 or more races. And the interesting thing is that people in that white category aren't just white, but include people from the Middle East and North Africa. And the Native Americans include people from North and South America and also Central America. People of Asian descent are from the Far East, Southeast Asia, or are from India. And the Native Hawaiians or the Pacific Islanders are from the Pacific Islands of Hawaii, Guam, or Samoa, or the Pacific Islands. And then two more races, from what I can gather, is any two of these races or more. And that's how the U.S. Census categorizes people who take these surveys. So back to statistics now. After all these CSV files are read in and a person's traits are determined, that person object with all of their data will be sent into the scenarios class, into this array of people. An array just holds all the instances of something. So if I had 50 people, this array would hold all those 50 people. And then from there, with that array of people from that certain scenario, and those scenarios can be a passerby, maybe a bus, a classroom, a bar, a campus, or a city, which is some random numbers I picked. That particular scenario with that array of people will then get called by this collect stats method, and it'll collect certain stats about that group of people. Like it'll collect the mean age, the median age, the oldest and the youngest, and the standard deviation of the age in that group. And it'll also collect proportions of female and male, maybe the intersex proportion, Hispanic proportion, LGBT proportion, and then all their respective proportions of races that the U.S. Census categorizes people into. And then from there, the dictionary of scenarios of that scenario will be updated with those facts. And then from there, a printout is done of all those traits into a nice little neat simulation statistics output, and then as well as a big raw output of all the data for each person, as long as the scenario isn't campus or city, because campus and city each having 14,000 and 50,000 persons is just too much to print out on the console, and it takes forever. So I spared you guys, and I put a condition up here to prevent that. So now I guess we should run it. So let me bring up a console and make sure that I swap to the directory that this Python file is in. That's important for when you run it. See, it is in this directory. We can see that simulation.py is the file that we want to run. It is in this folder. So then the command that you want to type to run this code is python simulation.py. And after you've installed Python 3.7.1 and that correct environment variable is installed, Python refers to a Python executable from the installed Python 3.7.1 that can run simulation.py. You run that. So now we get the little printout. WGSS 201 final project, Passerby Simulator by Ian Hecker. And then it just reiterates the purpose. It is meant to simulate, a person or a group of people that you may randomly encounter in the U.S. based on actual statistics. And then something important to note is that the U.S. Census and the Gallup poll all of U.S. People. So different spots of the U.S. have different proportions of race and age, sex, ethnicity. So if you were to encounter someone from this simulation, it would be from any person randomly chosen across the US, not a specific city, because again, proportions of age, race, ethnicity, and sex can differ, such as maybe a college town or I don't know, maybe somewhere down south where there's more African American people, or maybe a reservation in Montana where there are more Native American people. So that's important to remember. And then it shows where I've got my data from and those specific percentages, proportions. And then again, it shows for the output, when the output of the raw data of the people displays race, it will have either white, black, Native American, or Alaskan, Asian, Native Hawaiian, or other Pacific Islander, or two or more races as a race, but those can mean from these specific regions. It's just how the U.S. Census classifies people. So now we get to the printout of which scenario that we want to do as the list of how many people for that scenario. So you want to type in a number, 1 for passerby, 2 for bus, 3 for classroom, etc. 0 to end program, and you want to hit enter. And now simulation we'll call scenario, which calls person and generates a person. That person calling statistics to generate the statistics about the person, and then from there scenario will generate the statistics about those people or person. You can see here. So our person that we generated was 24, male, is not a part of the LGBT community, is not intersex, is Hispanic, and is 2 or more races. And now we have statistics about that person. And this isn't too helpful with just a simple passerby, but if we do maybe 10 persons, we now have a printout of the 10 people that the program generated, and the mean age was 27.9, the median was 26 years. We have an oldest was 59 and the youngest was 3 years old. We have 0 people that are Hispanic, which is interesting because about 0.2 of people are usually Hispanic from the U.S. Census data. And then we have different proportions of race and proportions of LGBT and intersex. And I think you guys get the idea of 10 and 50, so I'll go ahead and do a city scenario. Option 6 of 50,000 people, so 50,000 person classes will be generated, each with unique data, and it'll take a second or two. It's a lot of people. So again, because it's 50,000 people, there is no printout of the raw data because it's just too much. But from what we have, simulation of city, 50,000 people, we have our statistics. We had a mean age of 38.9, a median of 38, a standard deviation of 23.2, an oldest person was 100 and the youngest person was 0. We had a Hispanic proportion of 0.18, a proportion of Native Hawaiian and other Pacific Islander 0.0023, and we had pretty close to our percentages of those nationwide surveys by the Gallup poll and the Intersex North American organization of the proportions that they found. And because this is a random simulation, all these proportions will vary from scenario to scenario and from each run of a program to another. So in this case, we had some different proportions, different median, almost the same mean of age, and then different proportions of race. And you can see down here, intersex and LGBT are a little different from the last time. So yeah, if you guys run this program, I hope you have fun. I hope it clears up some idea of proportions of people out there. That's one of the reasons I created the program, was I was curious about how many proportions of people per age group, or LGBT or intersex, were out there, and thankfully the U.S. Census has some data on race and age proportions, and the Gallup poll and that intersex organization of North America. I keep butchering the name. Just go look what it was actually called. Intersex Society of North America have done studies on proportions of people to determine, what's out there, or the groups of people. So, and then 0 to end. But again, I've posted links down below about where to grab that Python version 3.7.1, and I've also included a Mac operating system, how to change your environment variable, down below. There's a YouTube video that he shows you how to change it. I've never run this program on a Mac or Mac software in general, but Python is cross-platform, so that should work. But yeah, thank you guys for watching. Also, I've included the GitHub repository down below, so you can tinker and play around with the code, or do whatever you want with it, because I've included an MIT license, which legally allows you to take and change and redistribute and do whatever the hell you want with the code. So have fun, and thank you guys for watching. Bye.